हेलो स्टूडेंट्स, मैं राज किरंगाले, आपका मैथ्स एंड साइंस कोच फ्रॉम स्टूडेंट फर्स्ट लर्निंग सेंटर हिंगनघाट। चलिए आज का लेक्चर शुरू करते हैं। लेक्चर को स्टार्ट करने से पहले वीडियो को प्लीज़ 480 पिक्सल यूट्यूब क्वालिटी में सेट कर ले और डिस्क्रिप्शन में दिए नोट्स को डाउनलोड कर ले।
Welcome to the next part of real number. My name is Raj Kirangale from Student First Academy. In earlier classes, we have seen Euclid division lemma and its two applications, especially finding the HCF of larger number. Further, we have also seen what is prime number and what is composite number, and how composite number can be represented as product of prime number. We call this prime factorization. Today, we are going to see LCM as well as HCF using this prime factorization. We have done this in our earlier classes, like in 7th standard also. So let us get it revised and let us see what is new in this. Okay. So we will understand this with the help of example. Find the LCM and HCF of 6 and 20 by prime factorization method. Okay. So we know first we have to represent 6 and 20 in their prime factors. So 6 can be represented as 2 into 3, and 20, if you divide it by 4, you get 4 and 4 into 5, and 4 can be represented in prime factor 2 square. Okay. So we know that HCF. How do we find HCF? We take what is common in these two, from these 2, 3 and 2 square and 5. So what is common? We take that as highest common factor, and in this case it is 2. In LCM, we'll multiply all the things, okay, and if it's repeated, we take from only one of the things. For example, LCM, that is all at once. So 2 square is here, so we take 2 square here. So we need not to take 2 here. Then there is 3, and then there is 5. Okay. So if you calculate this, it will be 60. Further, the addition to the knowledge is product of the two number. Okay, product of two number is equal to product of their LCM and HCF. Okay, you have to kind of remember this formula or concept. Okay, product of two number, that is, say two numbers are A and B. So A and B will be equal to HCF of these two number A and B into LCM of these two number A and B. Okay, you may apply it here and you will find that it is true. So this is it. Let us visualize this LCM and HCF using Venn diagram. Whenever we study just using variables, it becomes like a process, but whenever we do visualization, our concepts gets more clear. For instance, let us take the same example where 6 is 2 and 2 into 3 and 20 is 2 square into 5. Okay. So using Venn diagram, how will we represent 6? It can be represented something like this, 2 and 3. 2 and 3 completely make 6. Similarly, 20 is 2 into 2 into 5. So 2 into 2 into 5. Okay. So now let us see how to take HCF and LCM using Venn diagram. So if you represent, see 2 is common in both, so we can, like, if we take their union and see that 2 will be a part of intersection. 1, 2 is here, 1, 2 is here. Remaining 2, 5 we have written as it is, and remaining 3 we have written as it is. So whatever is common, okay, we call that as intersection, and that intersection is nothing but HCF, in this case 2. Okay. For LCM, we just multiply all these numbers, 3 into 2 into 2 into 5, and the answer is 60. So this is how to do the same problem using Venn diagram or visualization of LCM and HCF. Let us take example in this direction. Find HCF of 96 and 405 by prime factorization method. Hence, find their LCM also. So first we have to find HCF. We have given two number, and then we have to find LCM also. So how do we find HCF? First we have to represent them in prime factorization. So if you go on dividing 96 by 2, you will get that it is divided by 2 5 times. So 2 raised to power 5 into 3. This you can do in rough. I am writing directly as of now. Similarly, 404, if you see, can be divided by 4 easily into 101. 4 can be written as 2 square, and 101 in itself is a prime number. It is not divisible by anything. Okay. So what will be HCF? What is common in both of them? 2 square. 2 square is common in both of them. So HCF of these two number will be 2 square. Now we have to find LCM also. So we have two numbers and we have HCF and we know this formula. Okay. So we will use this formula to find LCM, that is A into B is used to HCF into LCM. We have A, B and HCF. LCM is unknown, so LCM is equals to A into B by HCF. Just put the value of A, B and HCF, okay, and you after calculation in rough you get something like 9696. Next numerical, find the LCM and HCF of these three number by prime factorization method. Till now we have seen for two numbers, now it is for three numbers. Okay, so 12 can be broken down as 2 into 2 into 3, that is in terms of prime factor. 15 can be broken down as 3 into 5. Similarly, 21 can be broken down as 3 into 7. Okay, so HCF, what will be HCF? What is common in all three? 3 is common in all three of them, so HCF will be 3. And for LCM, we take everything all at once. 2 into 2 plus 3, 3, 3. So 3 into 5 into 7. Calculate this in rough. Okay, 5 2s are 10 and 3 7s are 21 and 21 2s is 42. 42 into 10, 420. Okay. So, however, in this case, the product of number is not equal to HCF into LCM. Please note this. It works only for two number. Okay, A and B. If you put C, it won't work. This formula is applicable only for two numbers. Okay. So let us take few more numericals on this from our exercises. So exercise 1.2, second question from NCERT textbook. Find the LCM and HCF of following pair of integers and verify that. Okay, we have to find HCF and LCM and we also have to verify this formula. Okay, so the first is 26 and 91. Okay, let us express each of them as a product of their prime factor. So 26 can be represented as 2 into 13. Okay, this is prime, this is also prime number. And 91 can be represented as, it is not divisible by 2, 3, 5. So we divide it by 7. It goes 7 into 13 and these both are prime number. Okay, it's very clear that HCF will be 13. Okay, and LCM will be 2 into 7 into 13. Okay, if you calculate this, it will become 182. Okay. We also have to verify. So let's do the verification now. Let's multiply A into B equal to HCF into LCM. So A into B is 26, that is LHS. 26 into 91. Okay, the two number we get 2366. Now let us multiply HCF into LCM. So it is 13 and 182. The answer will be same. Thus we can say it's verified. Next, 510 and 92. Let us write them in terms of prime factor again. 510 can be written as 2 into 3 into 17 into 5. Similarly, 92 can be, if you go on dividing with 2 and then by, you get 2 into 2 into 23. Okay, so HCF, whatever is common will be HCF, that is 2. And for LCM, we will multiply everything. So 2 is here, 2 is here, 2 one time, this 2, then this 3. Okay, then this 5, then 17 and 23. So if you carry out this multiplication, you will get something like this number. Okay, let's do verification. Let's multiply A into B. Okay, 510 into 92, you get something like this. And if you multiply HCF into LCM, you get the same number. Hence, we can say we have verified it. Let's take the next question, 336, 54. Okay, let us divide them by 2, 3, 5 and 7, that is prime factor. So we get 336 something like 2 into 2 into 2 into 2 into 3 into 7. Similarly, we get 54 like this. Okay, so HCF is finding out the common thing. So 2 is common, then 3 is common. So 2 into 3 will be 6. LCM will be like 2 one times. Okay, then 2 second time, 2 3 times, 2 4 times. Then 3 1 times, 3 2 times, 3 3 times, and 1 7. So the answer is 3020. You can also verify that in similar manner. A into B, you carry out, it will something like this, and HCF into LCM you carry out will be the same. So exercise 1.2, third question. LCM and HCF of following integer by applying prime factorization method. Okay. So till now for two numbers, now let us see for three numbers. Okay, let us express it in terms of prime factor. 12 can be represented as this, 15 can be represented as 3 into 5, 21 can be represented as 3 into 0. Okay, so for HCF we want something common. Okay, so 3 is common, so HCF will be 3, and for LCM 2 into 2 into 3 into 5 into 7. Okay, so the answer will be 420. We cannot verify here because we know that it is not applicable for the three numbers 17, 23 and 29. Okay, actually these all are prime number. Okay, all are prime number, there is nothing we can do or we can divide by. So the HCF will be 1, only 1 is common, and LCM will be the product of these three numbers, which comes out to be 11339. Next is 8, 9 and 25. So 8 can be broken down as 2 into 2 into 2, 9 can be 3 into 3, and 25 as 5 into 5. So if you see anything is common except 1, so LCF will be 1, and however the LCM will be the almost product of all these three numbers. Okay, so it will be 1800. Given that HCF of two number is given and we have to find LCM. So we can use that formula. A into B is equals to HCF into LCM. We have given HCF and two numbers are given, so we will put them, and LCM is to be found out. So LCM therefore becomes this into this, divide by this. If you carry out this division in graph, you will get the answer like this. Okay. So this was all finding HCF and LCM using prime factorization. In our earlier classes, we have also seen the application of HCF. Okay, in finding the tiles in rows and columns and so on. So we will also understand what is the meaning of this LCM, why we are finding it. So what is its application, real world problem application. So for that we will take this question. So Sonia and Ravi are running over the ground, and Sonia takes 18 minutes to drive around a circular field. Okay, there is a circular field and Sonia takes 18 minutes to do that. Ravi takes same to run around same circular track. He takes 12 minutes. If they start at same time and at the same point, when they will meet at starting point. So I usually like to represent the question pictorially so that student gets more insight into it. So this is the scenario. Sonia takes 18 minutes to reach to the origin. Let's take this circle for Ravi, same ground. He takes 12 minutes to reach to the same point. So when will they meet? By the time Ravi completes his round, it's just 12 minutes. However, Sonia may be here because she requires 18 minutes. However, when Sonia comes to this point, it takes 18 minutes, so Ravi may have traveled here. So if they continue like this, when will they meet? So this is the problem of HCF. Okay, least we have to find what is common in between them and how earliest, that is least, they will meet. So let us break down this circular track into the straight line. So Sonia takes 18 minutes. So at origin she will be at 0 time. Then after 18 minutes also she will be at origin. After 36 minutes, that is multiple of 18, she will be at origin. Okay. Similarly, let us break down the circular track of Ravi. He will be at 0 here. Then after he takes 12 minutes. So at the multiple of 12, he will be at the origin. So at first 12. He will be at origin, but Sonia is not origin. Then at 24, he will be at again origin, but Sonia is somewhere here between the origin. And however, at third instant, he is at 36 and he is at 36. So this is the scenario of least common multiple problem. So in third round or after the completion of this first round, second round, after 2 rounds for Sonia, and that is 3 rounds for Ravi, they will meet. So this is the scenario where LCM problem are used, wherever something is in common we have to find and earliest. They may make even after, maybe after 6th round and 7th round, but we have to find the least. Okay. So if we take LCM also, this we have find through diagrammatically. If we take the LCM approach, LCM of 18 and 23, so this is 6 into 3, this is 6 into 2. So if you find the LCM, 6 is common, into 2 into 3, you will find the same answer, that is 36. Okay. So I hope by now we have completely understood HCF and LCM. Okay. So we will now begin with the next topic, revisiting rational and irrational number. Okay. In irrational number, we have seen various examples like root 3, root 5, root 2, pi, 1 by root 2. But we have never seen them in detail, or we have never proved them. So here we will going to be prove. For example, let's prove root 2 as irrational number. Okay. So for the proof of this theorem, or for the proof of this question, we are going to take help of the theorem, and the theorem is something like this. So if p be a prime number, if a p divides a square, okay, then it will also divide a. This is what we are going to use it. If a number divides a square, that is a square of a number, it will also divide a. Okay, this is simple. There is no such importance or proof of this theorem. We have to just use this to prove root 2 as irrational number. So we will use method of contradiction. What is method of contradiction? We will assume exactly reverse of this. Okay, and then at the end we find that our assumption is false. Okay, so what is reverse of this? Root 2 as irrational number. Let us say root 2 as rational number. Okay. Now, from the definition of rational number, we can write root 2 as a by b or p by q. Let's write a by b, where a, b belongs to integer and b not equal to 0 from the definition. And a and b are co-prime number. That is, they have only 1 as their HCF. These are the co-prime number. Okay. So that they are in simplest form. Let us square them both sides. So this become 2, this become a square and b square. Okay. And now let us arrange them, that is a square by 2 equal to b square. Okay. From the equation 1, it is very clearly that 2 divides a square completely, because remainder is, there is no remainder. It just, if you know the Euclid division lemma, there is no remainder. It means that 2 divides a square perfectly. Now using Ring theorem, we can also write that 2 divides a perfectly. Okay. Let's say this is equation number a or 1. Now, since 2 divides a square perfectly, from Euclid division theorem, we can write a, since 2 divide a completely, we can write a equal to 2 times, let's say quotient q, and remainder is 0. This is very easy. Okay. Now, let us put this in equation number 1. Okay. Instead of a, we will write 2q square. Okay. So, 2q whole square divided by 2 equal to b square. That is, if you divide 1, 2, it gets cancelled, so it will become 2q square equal to b square. Further, you can just rearrange this and you can write b square by 2 equal to q. Okay. Again, if you see this equation, you can conclude that 2 divides b square. Okay, because there is no remainder, it completely divides b square. So using the theorem, again we can write 2 divides b. Here it should be b completely. Okay. From equation 1 and equation 2, you see that 2 divides a completely, 2 divides b completely. So 2 is a common factor for a and b. Okay. However, this contradicts with our assumption that a or b are co-prime number. They cannot have a common factor. Okay. So we say that our assumption is incorrect, or hence we conclude that root 2 is irrational number. So this is method of contradiction. We assume something, we make its analysis, and then we conclude that our assumption is wrong, and hence the given statement is true. Okay. So we will be using same assumption or same, more or less same steps in our next proof. Okay. So exercise 1.3 from NCERT, first question. Root 5 as irrational. Same procedure. Okay. Method of contradiction. Root 5 rational. So root 5 is equals to a by b. Again same exact copy steps. ab belongs to integer and b not equal to 0. Both are prime number. Let square 5 equal to a square by b square. So we first take a square by 5. So a square by 5 equal to b square. 5 divides a square completely. So 5 also divides a. Question A. From Euclid, we can write, since 5 divides a, we can write a equal to 5q plus 0. Put in 1. Okay, again, a is 5q square. So let us put in 1. So 5q square by 5 is equal to b square. 5 get cancelled. So only 1 5 into q square equal to b square. We can rearrange this and write b square by 5 equal to q. Now this equation tells that 5 divides b square perfectly. So therefore 5 also divides a. So from 1 and a and b we conclude that 5, they have common factor as 5. However, this contradicts your assumption that a and b are co-prime number that we have taken earlier. So our assumption is incorrect, and hence we conclude that root 5 is irrational number. Okay. In the same direction, there is example 9, and which is for homework. Okay. So we will stop here as of now. See you in next lecture, in next class. Till then, signing off. Thank you.
आज का लेक्चर यही ख़त्म करते हैं। आई होप इससे आपको मदद होगी। मिलते हैं अगले लेक्चर में। तब तक के लिए गुड बाय एंड एंजॉय स्टडिंग।